The beaver problem expresses a cost-benefit type of analysis, but with poor information on the potential benefits. The cost-benefit type of analysis has parallels with the cost-benefit analysis of invasive alien species control presented in Hanley and Roberts, and with the cost-benefit analysis behind the social cost of carbon from last week. This figure expresses the net benefits of an invasive species management program as the value of avoided damage by controlling the invasion minus the cost of control and minus potential benefits from the invasive species. Translating this figure to the climate context from last week expresses the net value of climate mitigation efforts as the net benefits from avoided damage minus cost of abatement and minus potential benefits from warming. Similarly, the net benefits of ecosystem conservation or restoration can be formulated as the benefits from the target species minus the program cost and minus lost benefits from the status quo. In order to determine the benefits of preserving target species, it may be useful to first consider the wide range of ecosystem services. This figure, taken from the Worldwide Fund for Nature, formulates 19 ecosystem services in 4 categories, being provisioning services, regulating services, cultural services, and supporting services. This table by Costanza and colleagues in 1997, an article that kicked off much of the ecosystem service literature, gives more detail on some of the different ecosystem services. The 2017 paper included in the readings show that there exist alternative classifications, but that alternatives overlap when it comes to the 4 earlier mentioned categories. Costanza and colleagues point out that the value of provisioning services is easiest to estimate, as much of these services can be approached by using price information from markets. The regulating services and indirect value supporting services have more of a public goods nature, and cultural services could be considered a mix, making it more challenging to come to value estimates. When estimating values of nature, it makes some sense to distinguish between types of value. This figure from the Economic of Ecosystems and Biodiversity shows which methods can be used to estimate which types of value. Naturally, biophysical approaches such as material flow analysis or insurance value can also provide valuable input, but I focus here on the preference-based approaches. A first helpful distinction is between use and non-use values, where within the use values we can further distinguish between direct use, indirect use, and option value. Option value refers to the potential benefits from nature at some point in the future. An example that is often provided here is the value of species as potential medicines for yet to be discovered diseases. Somewhat less vague, the figure also lists replacement costs and avoided cost methods under option value. Use values still benefit from distinction between consumptive use and non-consumptive use. An example of the former would be fishing for consumption, while catch and release sports fishing or scuba diving would be examples of the latter. Non-use values differ from non-consumptive use values in the sense that for non-use values, visiting the resource in question is not necessary. For example, I have never visited the Great Barrier Reef, yet I attach value to its health. Or in terms of bequest value, I may never get to see a tree kangaroo in person, but I value that my nephews could potentially do so one day. In case of consumptive use, we often take the price of the natural resource in question as a proxy for its value. However, valuation is more difficult in the case of non-consumptive use because recreation in nature is often free. The displayed overview table from Hanley and Roberts show the most used valuation methods. Let us first focus on the revealed preference methods and start with the travel cost method as was first proposed by Hoteling. For one of the most used of Hoteling's economic insights, I will rely on a summary of Arrow and Lehman, because it is contained not in a paper but in a letter to the director of the National Park Service. The director had asked him and others how to measure the economic value of national parks. Since the entrance fee is relatively small, it is clear that people are probably getting satisfaction from the park well in excess of the fee charged. Hoteling noted that people usually have to travel considerable distances and thereby incur significant money cost. If we find the largest distance traveled, then those individuals can be thought of as getting zero net satisfaction. The value of the park less the transportation costs. Then all nearer individuals get a surplus that can be computed. By integrating over the population, we can get a total measure of satisfaction. This method, called the transport cost method, has been used numerous times to evaluate the social gain to parks and similar geographically defined sites. Let us consider a hypothetical park, where this example is taken from Perman and colleagues. The park authority kept visitor records depicted in this table by distance from the park. A first step in estimating the park's value is by finding a relation between the number of visitors and travel costs. Let's say we can estimate such a relationship with the help of ordinary least squares to control for other observable characteristics. Suppose that this procedure gives us park visits as a function of travel costs, specified as 10,500 visits minus 300 visits per dollar travel cost for this example. Now, in a second step, we take our estimated relationship at a hypothetical ticket price and estimate for each hypothetical ticket price how many people could be expected to visit the park. In doing so, we create a demand function for park visits based on hypothetical ticket prices. All we need to do next is integrate over this demand function to determine the consumer surplus of the park. In this example, this procedure suggests the value of the park of a little over $1 million, in case you want to check. Similar to this idea behind the travel cost method, people have used differences in housing prices to obtain estimates for the value of proximity to nature, or the negative value of noise pollution due to living near airports. These methods go by the name of cost methods and hedonic pricing. While the travel cost method may help us to get some estimate for recreational value of natural capital, the method has important limitations. For example, estimates depend on what one assumes as reasonable opportunity cost of time, how one treats distance to other parks that may serve as substitutes, and how one treats combined visits.